Welcome to the world of online learning. I am Dr. G.K. Biju, Professor, University of Garden City, Khartoum, Sudan. We at GK Online Learning Tutorial emphasize on the topics from software engineering, project management, quality management, strategic management, and mathematics. Today we are going to discuss the topics from software engineering. Please subscribe to our channel for continuous support. The next topic is COCOMO model. COCOMO stands for Constructive Cost Estimation Model, was proposed by Bohm in 1981. According to him, software cost estimate should be done through three stages: basic COCOMO, intermediate COCOMO, and complete COCOMO. So it's a regression model based on lines of code. It's a procedural cost estimate model for software projects and often used as a process of reliably predicting the various parameters associated with making a project, such as size, effort, cost, time, and quality. Different models of COCOMO have been proposed to predict the cost estimation at different levels based on the amount of accuracy and correctness required. All of these models can be applied to a variety of projects whose characteristics determine the value of constant to be used in subsequent calculations. So basic COCOMO model. The basic COCOMO model gives an approximate estimate of the project parameters. The basic COCOMO estimation model is given by the following expression: effort equal to A1 into kilolines of code to the power A PM. Tdev equal to B1 into effort to the base 2 to the power B months, where KLOC is the estimated size of the software product expressed in kilo lines of code. A1, A2, B1, B2 are constants for each category of software products. Tdev is the estimated time to develop the software expressed in months, and effort is the total effort required to develop the software product expressed in person per month or PM. There are three parts: organic, semi-detached, and embedded. So organic for effort, 2.4 kilo lines of code to the power 1.5 PM. Semi-detached for effort, 3.0 into kilo lines of code to the power 1.2 PM. Embedded effort, 3.6 into kilo lines of code to the power 1.20 PM. And organic Tdev, 2.5 into efforts to the power 0.38 months. Semi-detached Tdev, 2.5 into effort to the power 0.35 months. Embedded Tdev, 2.5 effort 0.32 to the power 0.32 months. So what is organic, semi-detached, and embedded? Bohm definition of organic, semi-detached, and embedded systems are: organic, that is, a software project is said to be in organic type if the team size required is adequately small, the problem is well understood and has been solved in the past, and also the team members have a nominal experience regarding the problem. And for semi-detached, a software project is said to be semi-detached type if the vital characteristics such as team size, experience, knowledge of the various programming environment lie in between that of organic and embedded. The projects classified as semi-detached are comparatively less familiar and difficult to develop compared to the organic ones and required more experience and better guidance and creativity. Examples: compilers of different embedded systems can be considered as semi-detached type. And embedded type, a software project with requiring the highest level of complexity, creativity, and experience requirement fall under this category. Such software requires a larger team size than the other two models, and also the developers need to be sufficiently experienced and creative to develop such complex models. The first level basic COCOMO can be used for quick and slightly rough calculation of software cost. Its accuracy is somewhat restricted due to the absence of sufficient factors consideration. The size of an organic software product has been estimated to be 32,000 lines of code. That is effort equal to 2.4 into 12 to the power 1.05, which is equal to 91 pm, and nominal development time 2.5 into 91 to the power 0.38, that is 14 months. Intermediate COCOMO takes these costs driven into account, and detailed COCOMO additionally accounts for the influence of individual project phases. That is, in case of detailed, it accounts for both these cost drivers, and also calculations are performed phase wise, hence for producing a more accurate result. Intermediate model. The basic COCOMO model assumes that the effort is only a function of the number of lines of code and some constants evaluated according to the different software system. However, in reality, no system's effort and schedule can be solely calculated on the basis of lines of code. For that, various other factors such as reliability, experience, capacity are also considered. These factors are known as cost drivers, and the intermediate model utilizes 15 such drivers for cost estimation, which comes under these attributes: product attributes, required software reliability, extent, size of the application database, the complexity of the project. Hardware attributes like runtime performance constraints, memory constraints, the volatility of the vital machine environment, required turnabout time. Personal attributes like analyst capability, software engineering capability, applications experience, vital machine experience or virtual machine experience, programming language experience. Project attributes like use of software tools, application of software engineering methods, and required development schedule. The third one, detailed model. The detailed COCOMO incorporates all the characteristics of the intermediate version with an assessment of the cost drivers impact on each step of the software engineering process. The detailed model uses different efforts multipliers for each cost driver attributes. In detailed COCOMO, the whole software is divided into different modules, and then we apply COCOMO in different modules to estimate the effort and then sum the effort. The 6 phases of detailed COCOMO are planning and requirement, system design, detailed design, module code and test, integration and test, cost constructive model. This is the end of the session. Please like, subscribe and share. If you are having any queries, please mail to me to the mail ID given in the slide. Thank you.